Okay, hello students. I'll wait a minute so I can log in here.
Professor, what's the module for today so I can open up the correct notes?
8.
8, thank you.
Yeah, module 8, I believe. Okay, Cassidy,
Here.
Alejandro.
Here.
I like your background, Cassidy. Very Charlie Brownish. Liliana,
Here.
Lainey,
Here.
Cassandra,
Here.
Romeo,
Here.
Brenda,
Here.
Jasmine,
Here.
Josue,
Here.
Jade,
Here. Here.
Valerie, Edsel,
Here.
Joel,
Here.
Monique, Salvador,
Here.
Caitlin,
Here.
Sheila,
Here.
Romeo Ramos,
Here.
Paula,
Here.
Ricardo.
Here.
Okay, thanks. Okay, so hopefully you saw my assignment. I'm changing my office. Oh, Valerie's here. Okay. I'm changing my office hours. Let me go back to the attendance real quick. Make sure I know Valerie's here. Okay, thanks. Okay, so I have a new office hour. Okay, I changed it because there was just too much conflict. And I didn't feel like I was being available to you guys. But new office hour is Monday nights tonight from 6 to 6:50 p.m. So if you go into ConferZoom, okay, it'll show every week from now until the end of the course my new office hour here. Okay, on Mondays, every Monday, there'll be a link to my office hour. If you want to come to my office hour and get some extra help, I'll be here from 6 to 6:50 at night on Monday nights. Okay. Yeah, absolutely. Thank you. Okay, along with that, I believe that you got an email from your counselor stating that there's also tutoring available. So keep that in mind, that there's tutoring at the tutoring center. So that's the math center here. So you just go to the math center and there's free tutoring. So if you're not available during my office hour, there's still free tutoring, and you just have to tell them that you need help with statistics, because or Math 105, because what we're going to be covering for the second portion of this course is statistics. So just tell them that you need help in statistics, and they'll get you a stats professor or a stats tutor, and they're there from 9 a.m. to 8 p.m. Okay, for tutoring on demand. This is on demand tutoring as opposed to my office hour, which is not on demand. Okay, so keep that in mind. Okay, any questions on anything up to this point? Okay, thank you for those of you that submitted your project. If you didn't submit your project, please get that in. I'll still accept it, but for partial credit. Okay, so I will take points off because it's late, but I'd rather give you some credit, some points than zero. A zero out of 100 is not going to be good for your grade. Okay. Okay. Okay, so let's get into today's notes. Okay, we're going to start working on statistics. That's why I'm hoping to offer Math 219 in the spring, because basically you will have done, you know, a lot of concepts that are in that class already by just taking this class. Now, you're not required to take that class, and for some of you, this may even be your last math class. Those of you that pass, you know, and are not in a STEM major. But I would encourage you to take statistics with me. If you were successful in this class in the fall, you might enjoy statistics with me in the spring. Okay, I'm trying to get it to be the same time as well, so it just, you know, for continuity, you know, it would be a little bit longer of a class. It would go from 2 to 4, just because it's much more intensive of a class, because we cover more material than we do in this class. Okay, but that class is 4 units instead of 3, so you do get an extra unit of college credit if you do take that class as well. Okay, so just keep that in mind. It's called Math 219. Okay, so let's start going over statistics material. Okay, just going to kind of read through this, and we're going to go through the examples. Statistics, collecting data. Statistics provides tools so that a person can react intelligently to information he, she hears and or reads. He, she, they, I guess. In this sense, statistics is one of the most important things that you can study. To be more specific, here are some claims that we have heard on several occasions. AT&T has the lowest drop calls. 4 out of 5 dentists recommend Dentyne. Almost 85% of lung cancers in men and 45% in women are tobacco related. Condoms are effective 94% of the time. People tend to be more persuasive when they look others directly in the eye and speak loudly and quickly. Statistics is collecting, organizing, summarizing, and analyzing information. Oh, there they are. Okay, perfect. Okay, so statistics is collecting, organizing, summarizing, and analyzing information so that intelligent conclusions are made using data to draw conclusions or answer questions. Okay, and we're in a kind of a election year, and so I'm sure you've seen a lot of statistics on the news. You know, like, you know, when they go to the polls, they're like, oh, there's 59% are for, you know, Biden right now, and 43% are for Trump, right? And that's a poll. These are statistics that somebody went out and they said, oh, I surveyed 1,000 people. Okay, and where were your 1,000 people? Well, we surveyed them walking out of Walmart. And 59% of the people shopping at Walmart, of these 1,000 people that I interviewed shopping at Walmart, 59% of them, you know, we're going to vote for Biden. 43% we're going to vote for Trump. Actually, sorry, 41. That should be 41. You can't have more than 100%. Sorry. 41% were for Trump, and nobody was voting for anybody else. So we're going to just make it really easy. Okay. So, however, there is a third party out there that is always on the ballot. Anybody know what that third party is called?
Libertarian?
Libertarian.
Green Party?
The Green Party, but the Green Party is not on every single ballot. But the Libertarian Party is on every single ballot in every single state. So there is a third party out there that you could vote for if you really wanted to. You know, if you hated the other two guys, you could just kind of have a protest vote, and you'd be like, hey, you know, I'm going to vote libertarian. But we're going to assume that there's only two parties here, which is unfortunately what the media assumes. And so we're just going to go with them, and they're saying, okay, who are you voting for, Biden or Trump? And there are people walking out of Walmart and be like, hey, 59% of the people are for Biden, 41% are for Trump, okay, and 0% are for any other. Okay, this is obviously not realistic. I'm just using this as a gross general example, okay, of a statistic, okay, of a statistic. Okay, so let's talk about the population and the sample here. Okay, the population and the sample. There we go. Okay, so the population and the sample. Before we begin gathering and analyzing data, we need to characterize the population. What's the population? Well, the population, think of population as the lake, and our sample as the number of fish in our net, right? So the population is the whole lake of fish, and our sample is taking this net, and we're going to net a certain sample. Does that make sense? So our population is the whole lake, and our sample is what's inside our net. Okay, so we're going to get a sample out of the population. Why? Because we don't want to have to survey the whole population. And sometimes that's not even possible. Would it be possible to survey every single human being in the United States?
If you arrest them, maybe.
Say that again?
If you arrest them, tell them that you're going to arrest them, they will probably do it.
They could do it? Well, what about the people that just died a second ago? What about the people that just got born a second ago? So you have people being born and people dying all within, you know, seconds of each other. That population, you'll never be able to get a full, you know, survey sample of the entire population. Does that make sense, Edsel? Okay, good. So again, you know, even in really, really large populations where we can get, where we could get the statistics on everyone, we may not want to. Think of, you know, so some populations that we have, the U.S., okay, people in the U.S. population. Okay, this is an unsurveyable population because it's simply too big and people are moving in and out of the United States. They leave, they move, they give up citizenship, they attain citizenship, they die, they're born. So that this fluctuates. Okay, that population fluctuates. Okay, what about if I said all of the players on the NBA? Again, this also fluctuates, but it doesn't fluctuate as fast. So I could find all of the stats on the players in the NBA. But I may not want to. Again, that's a lot of work. And I'm sure there's some website that's going to tell you the height of every single player in the NBA. But what happens when somebody gets traded? What happens when somebody quits? What happens when, you know what I'm saying? It's not always going to be up to date. So in those cases, the best thing that we can do is just take a sample and then generalize that sample for the whole population. Okay. So 8.1 says a dentist professor really wants to see if 4 out of 5 dentists prefer Dentyne gum over any other gum in his dental school. Okay. What would be the population here? What would be the population? Well, he's going to survey dentist at his dental school, right? Okay, or dental school students, right? So the population is the dental school students. Okay. Well, and it may not even be the dental school students. It may just be all the people that are at his dental school. So this is all the people, I'll just say people, at the dental school. Okay, so all the people at the dental school, okay, that's the population. Does that make sense? Because he may want to survey the faculty as well. Okay, so he's gonna out of this population. Okay, these are all people, all dental people. Okay, he may want to survey, you know, maybe 10 of them. Who knows? Okay, so it depends on what he wants to do. Okay, but he wants to see out of that 10 or out of that 100 or out of that 1,000, is it really 4 out of 5? Okay, he wants to see, does his sample match his claim, right? Instead of trying to survey the entire population, he'll want to survey a sample. Okay, a parameter is a calculated value, okay, using data obtained from a population. So think of it as like the average of a population, or how many of, you know, how many brown-haired people are there in a population, right? We could do a percentage. How many, you know, people over 6 foot are in the population as a percentage of total people in the population. So when we talk about a parameter, it's some sort of calculated value, but a parameter goes with a population. So it's P goes with P. Parameter goes with population. Now, if I calculate a value based on a sample, I'm gonna reverse this actually. Sorry. So for population, we have a parameter. Okay, sometimes that's average. Okay, so average, if it was average, we would call that parameter mu. It's the Greek letter mu. Okay, and this means average. That's the average amount of a population. This is the Greek letter mu. Okay, mu. How do you spell that phonetically? If I put 0, 0, it's going to be mu, and I don't want mu. I want mu. Mu. How should I mu? I don't know. That's muy. Mu. Oh, like Mewtwo. Mewtwo. Okay. Like Mewtwo, exactly. Mew. There you go. Okay, Mewtwo, which is, genetically modified Pokemon clone of Mew. Okay, so don't mess with Mewtwo. Okay, so Mew, as in Mewtwo. Okay, so this is the Greek letter mu, which is analogous to our U in the Latin English language, the Latin alphabet. Okay, U. The Greek letter is mu, and that's the Greek letter used for average for a population. Okay, if you have a sample and you have an average, it's no longer called a parameter. A sample is called a statistic. Okay, for a sample, we have a statistic, and that is, okay, so say that I wanted the statistic or the average of a sample, we call it something else. We call it X bar. Okay, this is called X bar. And that is also the average. Okay, and we'll get into more of this, but this is just, if you have a population, you have a parameter. If you have a sample, you have a statistic. That's all you really need to know from this. You don't need to know what mu and x bar are yet. Okay, that'll be in the future. But just know that if you have a population, you're running any calculation on a population, that's a parameter. Parameter. Let me write it better. Parameter. Okay, if you have a sample, then you run a statistic. Okay. Okay, a survey is an entire population is called a census. Oh, we've heard that term this year too, right? The census. If we survey the entire population, that's a census. Now the census in the United States, again, is not a true census because, again, people are coming in and out of that population all the time. But it's as close as we can get it to be. Okay. But we have a census, and that's a survey of an entire population. Okay. A sample is a much smaller subset of the population, ideally one that is fairly representative of the whole population. A statistic is a calculated value, average, percentage, etc., obtained from the sample. Okay. Okay, let's go back to our lake analogy here. To determine the average length of trout in a lake, researchers catch 20 fish and measure them. What is the sample and what's the population? Let's start with the population first. What's the population here that I'm looking at? I want to look at a certain characteristic for the population. What's the population? Paula says the 20 fish. Okay, Cassidy says trout. Okay. Okay, so again, let's use the diagram, right? Let's use the diagram. What is going to be, okay, what is going to be the population that we're looking at? We are looking at trout, right? We're looking at the length of trout. But what's the population going to be? Is it going to be the 20 trout that we catch? Or is it going to be all the trout in the lake? Yeah, but yes, exactly. It will be all the trout in the lake. So this is all trout in the lake. Okay, sorry about that. My microphone went on the fritz for some reason. Okay, so what's the sample in this case? What's the sample? I didn't catch that. That's a what?
20.
20 what?
20 trout.
20 trout. Yeah, the 20 trout that we catch. So this is the 20 trout that are caught. Right? So here's the 20 trout, and here's all the trout. Okay, the whole trout, and then out of that, we're going to select 20. So the population is all the trout in the lake. The sample is the 20 trout that were caught. Okay, good. Okay, a college reports that the average age of its students is 28 years old. Is this a statistic or a parameter? Is this a statistic or a parameter? A college reports that the average age of its students is 28 years old. Is this a statistic or a parameter? Okay, remember that parameter goes with what? What does parameter go with? Okay.
Goes with the population.
Thank you, Alejandro. It's the population. Okay, and the statistic goes with what?
A sample.
Yes, thank you, the sample. Okay, so the average age of a college, is that a calculated value on the population of the college, or is it a calculated value on just a certain number of students at that college?
Fair number of students. Well, just students.
It's the population, right? It's the whole average age of the entire college. They didn't say, oh yeah, I took 15 of these students and I ran a statistic. Does that make sense?
Yeah, all of the students.
Yeah, so you see the difference. They don't give me a specific number in a sample. And if they don't give you a specific number in the sample, then you have to assume that it's the whole population. So I'm going to go with parameter on this one. Okay. Okay, the average, okay, the average, or mu in this case, is based on the entire population. Okay, it's based on the entire population. Now, if they had said, we surveyed 100 students, then it would be a statistic. Okay, if they said, oh, we surveyed 10,000 students, it would still be a statistic. But if they said we surveyed the entire college, and this is the average age of students for the entire college, then it's a parameter. Okay, categorical data. Okay, 8.2, categorical data. Let's talk about this. Okay, categorical data, okay, is qualitative data. Our piece of information that allows us to classify the objects under investigation to various categories. Okay, this is a quality of someone, like if they have brown hair, or blue eyes, or brown eyes, or red hair. Okay, so if they have 5 fingers as opposed to 6 fingers, that's a quality of who they are, right? That's qualitative data. Okay, it's called categorical data or qualitative data. Okay, it's a category. Like what kind of car do you drive? That's a category. Oh, I drive a Honda, or oh, I drive a Ford, or oh, I drive a Toyota. That's a category. Okay, I can't add, subtract, multiply, and divide categories. It's just not allowed. I cannot add, subtract, multiply, or divide categories. Okay, in some cases, it doesn't make any sense to do that. Okay, regardless of whether or not that the category is a number or not, right? So say that I wanted to take a Honda and divide it by a Toyota. Does that make any sense? To take a Honda and divide it by a Toyota? What would I get? A Subaru? It makes absolutely no sense. Okay? So you cannot add, subtract, multiply, or divide categories. It's just not going to happen. Okay? That doesn't mean that categories can't be numerical. They can. It just means that if you add, subtract, multiply, or divide them, your answer makes absolutely no sense whatsoever. Okay? So that's categorical data. Quantitative data is numerical. Okay, this is numerical data. Okay, quantitative is numerical data. It's a number. Okay, and it's a number that has meaningful arithmetic calculations, meaning that you can add, subtract, multiply, and divide, and you get another piece of data out. Okay, the same type of data. Okay, so let's look at a couple of it. Identify each as qualitative or quantitative. Okay, and why? gender. Is gender a qualitative or quantitative piece of data?
Qualitative.
Qualitative, very good. Thank you. You are correct, qualitative. Okay, because this is a quality of a person, right? Their gender is a quality of who they are. What about temperature?
Quantitative.
Yeah, this is quantitative. This is quantitative. Okay. Can we add temperatures together? Yeah. Can I subtract temperatures? Yeah. Can I multiply temperatures? Sure. Can I divide temperatures? Sure. That's quantitative. Okay. My handwriting is awful today. Okay, quantitative. What about the number of times a college student works out in a 7-day week? Number of times a college student works out in a 7-day week.
Quantitative.
That is quantitative. And the way that I think about this, I always ask myself if it's qualitative or quantitative, is can I get the average? Can I get the average? Can I get the average number of times somebody works out? Sure. Can I get an average temperature? Sure. Can I get an average gender? No. There's no average gender out there. Okay. If I add two genders together and then divide by 2, I don't get another gender. Right? If I add 2 temperatures together and divide by 2, I get another temperature. That's kind of cool. If I add the amounts that one person works out to the amount that another person works out and divide by 2, I can get the average amount. And if I can get the average, then it's quantitative. If I cannot get the average, then it's qualitative. Does that make sense? Okay, so with that said, what's the next one here? Zip code. Somebody give me their zip code. What's your zip code? Somebody tell me your zip code.
92707.
92707. Okay. 92707. I had another one, 92701. That one's too familiar. I'm gonna go with the other one here that I think Paola put in the chat box. Oh no, Laney did. 92843. 92843. 92843. Okay, is this quantitative or qualitative?
Qualitative.
Why? Alejandro, why? Why is it qualitative?
Because it's like not, you can't add them together or like divide them by each other. It's not like numerical data, it's qualitative. It's like where you reside in that area.
Oh, that was the best explanation I've gotten, I think, from any statistics class. Okay, did you hear what he said? That was such an amazing explanation. That's exactly how I would have explained it. Okay, the zip code, even though it's a number, it is a quality of where you live. Some people live in 92707. Some people live in 92843. If you try to add these together, do I get another zip code?
No.
If I were to add these together, I would get 18,000, right? So, right, I would get, oh no, this would be like 184, this is 0, 4, 5, 5, right? So what was this, 185,005. Do I get another zip code if I add them together?
No, that number isn't significant to the zip code.
Yeah, it's not significant. What if I were to take the average of these two? This would be like 9, 2, 7, 6, 2.5. Is that a zip code if I were to take the average? No, there's no 0.5 zip codes. So it's a qualitative piece of data. It's a data that it just tells you, okay, it's basically a code, and a code is always qualitative. This is a code that tells you, oh, this person lives in this area. Okay, it's a numerical code. Okay, and so when we want this to be qualitative. Okay, so what about hair color? That one's pretty easy.
Qualitative.
Okay, and what about height in inches?
Quantitative.
Yeah, quantitative. Okay. Okay, that's all I got for you today. Your job, should you choose to accept it, is to work on the homework. If you get stuck working on the homework, I'll be around at 6 o'clock. Okay?
Yeah.
Okay. And again, if you didn't get your project in, get that in.
Thank you, Professor.
Yes, this will go up on YouTube. Yes. Okay, I'll see you guys on Wednesday.
All right. Thank you.